So we've done watercolor techniques, and now we're going to get into color theory, because that's going to be the other huge component of learning to paint with watercolors, or really just painting in general. Because the biggest difference once you're starting to paint versus most of what you've done in drawing is going to be learning how to manipulate color. So I've already kind of laid out all of the colors that were on your supply sheet here, and then just put a little sample next to it and put some abbreviations. And you all are going to need to take these notes too. You're welcome to take them along with me, or if it's easier for you to do them later, whatever's easiest for you is fine. So these are all of the colors you were required to get. If you have more colors than these, I would go ahead and add them on here, just so that you have kind of a sample. And then I would also consider labeling them in your palette, because a lot of times once the piles are dry, like from here without like adding water, it's really hard to tell that this is the phthalo blue and this is the ultramarine blue. And then I also added down here, these were not required to get, but I am going to talk about them because I think that it's really helpful. And then these are the CMYK watercolor gouache set by Hans Holbein. And if you are interested in getting these, just let me know. I can send you a link. They're a little spendy, so I didn't include them on the supply list, but CMYK is really important to color theory, so I am going to talk about them. So we'll just start off right at the top talking about color theory. And the first thing that I'm going to talk about is color systems. So we have additive and subtractive color systems. I'm going to talk about additive first because it's something that you need to know in understanding color, and it's something that I'm required to teach, but this is not the one we're going to spend the most time on for this class. And you'll see why shortly. So going over so for an additive color system is just mixing light. So that is, let's see, the primary colors in an additive color system are going to be red, green, and blue. And a primary color is just going to be colors that cannot be mixed. The secondary colors are cyan, yellow, and magenta. So additive color works by mixing light. And it's called additive because you are just adding light. There's nothing else in play but light. Additive color is how our eyes perceive light. So things that use additive color, our eyes use additive color, screens, really anything digital. So in our eyes, we have what are called cones and rods, and these help us perceive color. And those rods are our primary colors. So you're going to have red, green, and blue rods. So we have our visible color spectrum, which is going to be the rainbow. So it's going to start from red and go down to violet. And so red, orange, yellow, green, blue, indigo, violet. So rods are always going to be red, green, and blue. And so it happens whenever we're seeing certain colors that are not red, green, and blue, what's happening is rods that are red and green will be both activated if we're seeing orange or yellow in varying amounts. And then same with if we're seeing violet, that means that our blue and red cones are activated. I'm just going to make a little color Venn diagram here just to kind of help get the visual. And again, this is going to be mixing light. So this is not actually how it would be mixed with paint. I'm just going to put the colors directly on there so you have the visual. So red, and again, I know you guys don't have the magenta, yellow, and cyan colors. You may if you took foundations, because at one point it was required in the foundations kits. So if you have them, I highly encourage you to dig those out. They are helpful. And then in the middle, if you mix all of these colors of light together, it's going to be white. White is all color shown at once. I'm just going to draw like a little lamp here to kind of show. What's happening here. So for example, if we have a yellow light, and a blue light. Oops, sorry. I meant to put green down here. So if you have a green and a blue light, the light itself coming together makes cyan. So the easiest way to remember the additive is adding light, and then think about it in terms of being perceived. So the way that our eyes see even mixed color is using this system. Color is just reflected light, and so it is that light directly being perceived by our eyes. So our eyes are doing the work of activating the cones to mix that color so that that's what we're seeing. Now, we'll spend more time on subtractive. So the primary colors in a subtractive color system, we have a few different sets that are commonly used. So in this class, we will primarily use red, yellow, and blue. But it's becoming more and more commonly accepted to use magenta, yellow, and cyan. And I can't stress enough, like, color theory, it's called theory for a reason. These are things that are being experimented with, and they're still figuring out how it works. And that's how we end up with different color systems. So for the primaries with the red, yellow, and blue, I want to point back out at the visible color spectrum. And I want you to notice that this is linear. This doesn't curve around and connect into the color wheel like we use in art classes and like we'll make later on. And so what's missing here in between red and violet is magenta. Magenta is not on the visible color spectrum. Magenta is something that our brain makes up to kind of fill in the gaps. Our brain imagines what it would look like if you're mixing that red and violet together. Our brain makes a lot of leaps like that. If there's actually like a hole in your vision that your brain fills in, you see things upside down. Like our eyes perceive things upside down and your brain flips it around. And magenta is one of those leaps that it makes. And that is just like the visible color spectrum as it is to humans. There are plenty of animals that see a much wider range of light. So subtractive color systems they're called subtractive systems because you are subtracting light. Hang on, let me how do I want to do this? I'm going to just note the secondary colors underneath here really quick. Okay, so with the red, yellow, and blue, secondaries are going to be orange, green, and violet. The magenta, cyan, and yellow, our secondaries are going to be red, blue, and green. And I want you to notice that the secondaries and primaries are opposite when we're talking about additive and subtractive. So what were our primaries in subtractive are the secondary and additive, vice versa. So with additive being how light is perceived, subtractive is going to be how light is communicated. And this is used with mixing pigments. Not even just mixing pigments. This is, you know, if you're looking at this orange, the fact that it is orange and it is communicating orange, that is part of the subtractive color system. Printers in particular use a CMYK system. CMYK gets a broader range of colors. Red, yellow, and blue, you can still get a really wide range, and we'll go into that a little bit as well, but you can get a way wider range with magenta, yellow, and cyan. If you're having trouble mixing a color with these, it could be because it's something that you might need cyan or magenta. When you think about the photos that a printer can make, it can make just about any color using the magenta, yellow, and cyan. So I'm gonna do kind of the same thing here. And since I'm not trying to mimic light here, I'm actually using pigments and can mix pigments, I am gonna just mix together the magenta and yellow and cyan so you can see what they actually look like mixed. And I'll actually move the palette over so you can really see it. So mix together my magenta and and yellow. And we've got our red. Mix together cyan and magenta, and we'll get a blue. Oops. And then yellow and cyan to get our green. And then we mix all three together. And it takes a while to get kind of an equal mix. This is where we're getting neutral colors, and if I can balance out the exact same amount of pigment of all three, we'll eventually get to black. And that's probably about as close as I'm gonna attempt to get at the moment. And again, with subtractive color, black is the absorption of all colors. So and that's why when you mix all of them together, you're getting the black. And just kind of a diagram to see how this works. So say we've got our lamp here. So with light, if we've got a white light, which most of our lights are, if you remember from up here, we've talked about white light being all colors of light mixed together. So that means that in this white light, we've got our red, orange, yellow, green, get a little more pigment there, blue, and violet. So all of those colors are coming to bounce off of something. So what's happening, so say we're looking at this orange. Go ahead and draw. So we've got our orange here, and so what's happening with subtractive light is when this light is all hitting the orange, it is subtracting all of these colors except for orange. And just in case you can't read, I just wrote next to the white light that is all color in the visible light spectrum mixed together. And I'm writing that the orange absorbs / subtracts all colors of light except for orange. Which then is bouncing back to our eyes and being perceived using additive color. Because again, it's reflecting off light. So again, subtractive means we're subtracting light. We're subtracting all of these colors of light except for orange. Okay, so now we're gonna knock out just a little bit of color vocabulary over here. So I'm just gonna kind of make a little divider. So color is just reflected light. A primary color is a color that can't be mixed. And so again, this is kind of where the idea of red, yellow, and blue being the main primaries has kind of been debunked, because I mean, you watched me mix red and blue. Yellow is still one of those primaries though. secondary color is mixing equal parts of 2 primary colors. And then also going to talk about tertiary colors. That's going to be mixing the primary with an adjacent secondary color on the color wheel. Okay, we are gonna stop there for just a second and go ahead and make a color wheel. And don't get ahead of me here because I want you to do it in a really specific way for me. So we're gonna take up a good portion of this half of the paper. So I'm gonna put primary here. I'm just gonna kind of put that in a little box. And I'm gonna just rotate things around a little bit. So going back to the colors that you have in your kit, we're gonna put down 2 of our reds, 2 of our yellows, and 2 of our blues, and specifically, I do want you to label things just so that you can keep track as we go. I'll put them down first and then label. So closer to the yellow, I want you to put the cadmium red. And then towards the blue, you're going to put the alizarin crimson. And then for the yellows, towards the red, I want you to put the cadmium yellow. And if you have 2 cadmium yellows, it's going to be the cadmium yellow deep. And then towards the blue, we're going to put lemon yellow or cadmium yellow light, depending on which watercolors you got. And then You're going to take phthalo blue and you're going to put that towards the yellow. And then you're going to take the ultramarine blue and put it towards the red. And this placement is important as we're going to start talking about temperature later, because I want you to pay attention to so as we've already talked about, these aren't going to be the purest primary colors. These are not the magenta, cyan, and yellow. So these colors are all kind of leaning one way or another, and even if we get the purest yellow possible, it's gonna kind of lean one direction or another. So the cadmium red is a little bit orangier, which is telling us it's leaning a little bit more yellow, a little bit more towards a warmer color, where the alizarin crimson is leaning a little bit more blue. So it's leaning towards a cooler color. We've got a warmer red and a cooler red. And then for the blues, our phthalo is leaning a little bit more green, which means it's got a little bit of yellow in it. So that one's leaning a little bit cooler because red's a warmer pigment. So it's leaning green. So then this one, the ultramarine, is leaning a little bit more violet, a little bit more red. So that one's going to be warmer. So even though red and yellow are both warm pigments, red is a warmer pigment than yellow. Temperature is relative. Okay. And then go ahead and label those. I made my little abbreviations next to here. And then go ahead and kind of indicate a circle. You can fully draw out a circle or just kind of dot it out. Then we're going to put our secondary colors. So again, secondary, going to be mixing equal parts of those primary colors. So first I'm going to go with the cadmium red and cadmium yellow. And I'm going to put that outside the circle here. I'm actually going to add a little bit more yellow to that. It's a little more red than I was going for. There we go. It's a little oranger. And then I'm going to do cadmium red with the lemon yellow or the cadmium yellow light. I'm mostly going to refer to that as lemon yellow, so if you need to label your tube to just remember which one I'm talking about for the cooler yellow. Okay, then I'm gonna do cadmium yellow and alizarin crimson. And then I'm going to do the lemon yellow and alizarin crimson. I'm going to go ahead and label those before moving on. So we've got our oranges. This one is going to be cadmium red and cadmium yellow, cadmium red and lemon yellow, alizarin crimson and cadmium yellow, then alizarin crimson and lemon yellow. Oh, that was okay, and then our greens are going to be here. And violets here. So I'm going to keep doing that same thing. I'm going to wipe off a little bit of my palette here so I have a little more room to mix. Okay, so first I'm going to take cadmium yellow, and some ultramarine blue, going to take the lemon yellow and the ultramarine blue. More blue in that. Okay, then we're going to take the cadmium yellow with the phthalo. I'm going to take the lemon yellow with the phthalo. And then notice really quick on your color sheet, you do have the sap green and viridian green. And I want you to go ahead and place those. I'm going to put the sap green closest to the yellow. Grab. And the viridian green closer to the blue. And don't forget to label all of those. Okay, so SG for sap green. We have our cadmium yellow and ultramarine blue. And then lemon yellow and ultramarine blue. Cad yellow and phthalo blue. And lemon yellow and phthalo blue. And then we've got the viridian green here. Okay, we're going to do the same thing with the violets. So I'm going to take alizarin crimson and phthalo blue for the one that's going to be the closest to blue. And really take your time on these, guys. This is going to be a good reference for you throughout the semester. Okay, Okay, and then I'm going to take the alizarin crimson with the ultramarine blue. Blue heavy there. There we go. You see me keep kind of going over ones I already did. It's because I'm trying to balance the same amount of pigments for each of them. And then I'm going to take cadmium red and phthalo blue. And just to kind of note like how much stronger the red is than the blue in this case. Like, look how drastically warmer that got with the cadmium red versus the alizarin crimson. Okay, and then the last one, I'm doing the cadmium red with the ultramarine blue. I'll remix that. I think I got my piles mixed up a little bit. Yeah, there we go. And then don't forget to label these. So we've got our phthalo blue and alizarin crimson. Got our ultramarine blue and alizarin crimson. We've got our phthalo blue with cadmium red, and our ultramarine blue with cadmium red. And then I'm not gonna have you guys mix out every single possible of the tertiary colors because it's gonna end up being this multiplied by a lot. so let's see, which ones do I want to do? So essentially, if you don't keep straight your piles of the pigment, you can just mix a little bit more of one of the primaries than another. So I'm gonna do, I'm gonna kind of split them in half. On these ones, I'm gonna add more yellow, and on these ones, I'm gonna add more blue. Or, sorry. Okay, so I'm gonna pick I'm gonna go ahead and label these. So I'm gonna have yellow orange here. And for the tertiary colors, you're always gonna list the primary color first. Okay. Oh, and our red oranges. Okay, so for the red oranges, I'm gonna take these mixtures and I'm just gonna add more of whichever one of these reds that I have in there. So for, clean off a little room on my palette again. Drop. Okay. So the first two have more of the cadmium red. So I'm gonna go ahead and just kind of dollop a fair amount of cadmium red there so I don't have to rinse my brush quite as many times. Okay, do the cadmium yellow. gonna take cadmium red here and mix it with a little bit of lemon yellow. Again, for these ones, they should lean more red. And again, I am not making you guys mix all of the possibilities here, because, you know, I could have you guys mix this one with alizarin crimson, or, you know, keep building it that way. But if you want the challenge, go for it. And then getting some alizarin crimson in here. And then a lemon yellow with the crimson. Okay, and then so just to kind of notate that I've added more of the reds on this one, I'm going to put cadmium red ×2 and cadmium yellow, cadmium red ×2 plus lemon yellow, alizarin crimson ×2 and cadmium yellow, and alizarin crimson ×2 plus lemon yellow. And you can actually take the piles that you just mixed and add those with yellow. So this is our alizarin crimson with lemon yellow. This one is our cad yellow with alizarin crimson. Cad yellow and cad red. Leave space there because I went a little out of order. And the lemon yellow with cad red. So Cad Red plus Cad Yellow times 2. Cad Red and Lemon Yellow times 2. Alizarin Crimson and Cad Yellow times 2. And Alizarin Crimson and Lemon Yellow times 2. Clear out another spot on my palette again. And I know that this is a little monotonous. I promise not all of the lessons are quite this long, but color theory is really important. It is the #1 most important thing in learning how to paint. And I'm sorry for anybody who already has a really great grasp on color theory, but hey, we're just gonna solidify that a little bit. So first I am gonna take the sap green, and I'm gonna just mix it with the cadmium yellow. And if it makes you feel any better, I am doing this with you guys. I'm spending just as much time on this. And I am just going in the same order and just doubling up on the yellow, so. And when I get to the Viridian green, I'm just gonna mix it with the lemon yellow. If you wanna go ahead and mix it with both to kind of expand your color mixing, go ahead. That lemon yellow, a little bit of phthalo. have our yellow greens. Did I skip one? I did. Okay. That one's okay. So I'm going to do the sap green and the ultramarine blue. Okay, and then for the Viridian green, I'm going to add the phthalo blue. Did not add quite enough blue in that one. And that was too much blue. There we go. Phthalo blue and crimson, cadmium red, sorry. She's dark. Too much blue. A little more cadmium red. Yeah. Okay. And that is where I'll stop today. I will post the next video continuing color theory notes tomorrow. And we should be done with color theory notes and kind of getting watercolor techniques and kind of some basics down by Sunday. And I will make sure that you have adequate time from the time I post videos to get the work done. If you have any trouble with that, just let me know.